Good afternoon. So let's talk about developing the concept on the topic of non non-uniform motion. Okay. All right. So we know that uniform motion, the uniform motion which you are already aware of, has you know no change in velocity. So there is no change in velocity, which means the direction and magnitude, both of them, remain constant throughout the motion. But then, you have a certain type of motion in which the velocity, does not remain, does not remain constant, and that is what our focus is. Right? It does not remain constant. So motion, is categorized as non-uniform motion. I'm just writing a short form, non-uniform motion. If the velocity keeps on changing as the time progresses. Now, as an example, if you have a body, which is starts from a point zero and then it reaches a point A, and during this time, the velocity of the body, for example, is 5 meter per second. And then from A to B, the body, at B, the velocity of the body is 10 meter per second. At point C, the velocity of the body is 20 meter per second. And all of this, is happening, for example, in 1 second. So the time elapsed is 1 second. So you can see the body changes its velocity throughout the motion. And maybe, after some time, maybe 2 seconds, the velocity of the body is, 50 meter per second. So such a motion in which, and I've considered a linear motion, 1D motion, such a motion in which the body keeps on changing its speed or velocity, because we're considering only 1D motion here, the 1D motion. That is, our direction remains constant. Only the magnitude is being considered. If you look into this, such a motion in which the body keeps on changing the velocity. So your chart is, if you were to measure the velocity after 1 second, you would get 5 meter per second, right? And at 2 seconds, you would see that the velocity of the body is 10 meter per second. At 3 seconds, the velocity of the body is 1 meter per second. And, after 5 seconds, because I mentioned 2 seconds here, the velocity of the body is 50 meter per second. Now, if this were a uniform motion, whenever you would have measured the velocity of this body, it would have remained 5 meter per second, right? So this remains 5 meter per second. Okay. So this type of motion in which the velocity remains constant, although the time progresses, is called as uniform motion. But this type of motion in which the velocity keeps on changing as the time progresses is called as non-uniform motion. So I think you should have a clear sense when you do the numericals, what type of motion it is. Most of the motion in the world is non-uniform. You never move with the same velocity. Either your speed is increasing or your speed is decreasing. I'm using the word speed and velocity interchangeably because I'm considering 1D motion in which if you have one dimension like only x-axis, the distance is equal to displacement, okay, because the start point and end point remain unchanged in 1D motion. The velocity also becomes equal to speed. So you can use the words interchangeably. Don't get worried about the use of word velocity or speed when it's about 1D motion. Okay, the direction is in the straight line, and therefore both the scalar quantity and vector quantity fortunately have the same magnitude. So we're talking from magnitude point of view. But coming back to the topic of non-uniform motion, so the non-uniform motion is characterized by continuously changing velocity, which is very real-world application. But the uniform motion is a very idealistic form of motion in which the velocity throughout the motion remains constant. Thank you very much. And if you like this video, please give me a thumbs up and subscribe to my channel. Thank you very much.